To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all the function of transistors. Now in the previous chapter we discussed what transistors are. When you have two p-n junctions by connecting three semiconductor regions, either NPN or PNP, we get the transistors. So there we discussed in details how the transistors are, the semiconductor regions are present in a transistor, then the standard symbol of a transistor, and also how the charge carriers flow, the current flows, and how to indicate the emitter terminal using the arrowhead that indicates the direction of the current flow. And finally, we discuss biasing of transistors. You all can remember always the emitter-collector junction, the emitter should be forward biased. So, emitter, if it is a PNP transistor, emitter will be connected to the positive terminal of the battery. In an NPN transistor, emitter will be connected to the negative terminal of the battery. So, the collector and the base are connected in the same manner. In an NPN transistor, collector is connected to the positive terminal of the battery. The same way, base is also connected to the positive terminal of the battery. When we do this connection, the base emitter terminal and the emitter collector junction both will be forward biased. But the base collector junction will be reverse biased with a higher voltage. So that is how we bias the transistor. Now I am going to discuss with you all the functions or how we use transistors. And if you can remember students, in all our activities, we will be using NPN transistors. So the first function of a transistor is the amplifying process of a transistor. Now when you say amplification, you all can understand that term. We increase something. If you amplify sound, the volume of the sound will be increased. Or if you amplify a signal, you can increase the amplitude of the signal. So like that, we do the amplification process. So amplifying process of a transistor. Here we use it as a current amplifier. So if we increase the current. Now we all know when we increase the current, to identify that the current is being amplified, what we can do is we can use bulbs. From the brightness of the bulbs, we can identify the amount of current flowing through that circuit. If the brightness is less, you all know current is less. If the brightness is more, you all can identify that the current is more. So that is how we are going to understand the amplifying process of a transistor as a current amplifier. So when we say current amplifier, basically a transistor is used as a current amplifier. When a small DC current, what is a DC current? A direct current, a current that does not change direction with time, or current that flows only in one direction in a circuit. That is a direct current. So when a small direct current is supplied as the input of a current amplifying transistor circuit, a large current can be obtained as the output of the amplifier. So we provide a small input current to a transistor. Then you will get a large output current. So we give a small input current to the transistor circuit. This is given to the transistor circuit. From there, we get a larger output current. So that is the amplifying process. So if you use a light bulb to identify this. Now here, like I told you all, if we use a light bulb bulb. Now with a small current, brightness has to be less. Brightness less. And with a larger current, brightness will be higher. Brightness is higher. So then we can understand the amplifying or current amplification process. So to understand this, we will do an activity. So I'm going to move on to the next slide. Activity, transistor as current amplifier. So to do the activity, we need different materials or apparatus that are needed. So we need a transistor. Usually it is the NPN transistor. Then we need torch bulbs. Torch bulbs. We need batteries. Batteries, normally we need 3-volt batteries as well as we need 1.5 volt batteries. So here these are also different types of batteries because we need to supply different voltages. Then we need button switches. Switches or button switches. These are more better, easier to use the button switches. Then we need a volume controller as the resistor. Volume controller and the circuit board. Circuit board. So these are the required apparatus. We need the transistor. It has to be an NPN transistor. Then we will need torch bulbs. We will need 2 torch bulbs. One for the input circuit and the other one for the output circuit. Then we will need batteries. We might have to supply a higher potential and lower potentials. So we will need 3-volt batteries and 1.5 volt batteries. Then we will need switches. And like I said, the button switches are more convenient to use here. Then the volume controller, this is a variable resistor. So you all know the function of a variable resistor. Variable resistors are used to control the current flow through the circuit by controlling the or adjusting the resistance. If the resistance is high, current flow will be less. When the resistance is less, current flow will be more. Then we need a circuit board to connect all these apparatus. So those are the materials needed. Now we will look at the method in the next slide. So method, construct the circuit given in the figure on the circuit board. So we will look at the circuit board. Before that, I will show you this diagram. Now here you can see this is the volume controller. I have shown you all volume controllers in the previous year. You are familiar with that. It is a variable resistor. You can rotate it to change the resistance. Now the volume controller has 3 terminals. 1, 2, 3. They are labeled as 1, 2, 3. So you can identify them easily in the circuit as well. To observe how you connect the volume controller to the circuit. Then here you can see this is a D400, SD400 transistor, an NPN transistor. So when you have the terminals facing towards you all, it has a shape of a semicircle like that. The flat surface will be on top, the curved surface will be below. And towards your left side, it's the emitter, middle is the collector, and base is going to be the right side terminal. That is when the terminals are facing towards you all. Then we connect that and attach it to the circuit board. So this is how we are going to have the circuit. You can see here, students. Now this is the transistor. So when you look at the symbol of the transistor, you use the arrowhead to identify the emitter. Always base is going to be this. Emitter has the arrowhead, and from this you know arrowhead pointing outwards is the NPN transistor. So emitter, collector and the base are shown like that. Then what we do is we connect the base terminal to a bulb L1 and thereafter the bulb is connected to the volume controller. Now here you can see 1, 2, 3, the 3 terminals of the volume controller. This is how we connect it. Terminal 1 has to be connected to the bulb, and then 2, then 3 is connected there. Then that part, the volume controller is connected to a 3 volt potential difference. Now we said we are using 2 types of batteries. 2 3 volt batteries and 2 1.5 volt batteries. So here we will be connecting 2 1.5 volt batteries. So the positive terminal is connected to the base. Negative terminal to the switch S1 and then to the emitter, the negative terminal. So this is an NPN transistor. You all can understand the base emitter junction is forward biased. At the same time, here again you can see the emitter terminal is connected to switch S2 and that is connected to the negative terminal of the other battery where we provide 6 volt potential. 2 3 volt batteries. Then that is connected to bulb L2. So what will happen is the emitter junction is also forward biased. Emitter collector junction is forward biased. And here you can see less potential difference, higher potential difference, or less voltage, higher voltage. That is how we forward bias these two junctions. So automatically the base collector junction will become reverse biased. That is how we connect the circuit. Then what we do is we need to adjust the volume controller so that the bulbs will light. And at the same time, you have to observe the bulbs when both S1 and S2 are open. Then you close S1, keep S2 open and observe the bulbs. You open S1, close S2 and observe the bulbs. Close both the switches. Both S1 and S2 are closed and you observe the bulbs. So 4 different instances in which we need to observe the bulbs. You need to observe whether they light, and if they do, you need to observe their brightness. Then only you will understand the current amplification process. Is that clear, students? So then we will go through the method again. Here you can see, construct the circuit given in the figure on the circuit board. Attach a pair of dry cells to each of the battery covers before connecting them to the circuit. Terminals of the volume controller, that is the variable resistance, and the transistors are indicated in the circuit. So these are the terminals and how they are connected in the circuit is indicated to you. The procedure continues. So there, switch S1, the 3 volt battery, the volume controller VR and the bulb L1 are in the input circuit. So they are input circuit. So here this is going to be the input circuit. Input circuit, and this will be the output circuit. We will supply the current to this and we will observe how the current is amplified in the output circuit. So, input circuit, the current will be observed by L1 and the output current will be observed by the brightness of L2. So, that's how we understand the function. Then, so here we said switch S1, the 3 volt battery, the volume controller VR and the bulb L1 are in the input circuit, while the second 6 volt battery, switch S2 and the bulb L2 are in the output circuit. The battery should be correctly connected while the switches S1 and S2 are in the off position. So when we say correctly connected, the terminals of the batteries being connected to base, collector and emitter have to be done correctly. Then first turn on S1, that is close S1 and adjust the resistance of VR until the bulb L1 just begins to light up. So that is important. Adjust the resistance of VR until bulb L1 just begins to light up. Now turn off, that is open switch S1. So now the circuit is ready to operate and to get the observation. Initially we adjust the volume controller so that the bulb just lights up with the minimum brightness so that you can observe the current amplification process. Like I said, if the brightness is less, less current. If the brightness is more, more current. Then open and close the switches S1 and S2 as indicated in the table below and observe the brightness of the bulbs and fill in the table. So here you have the table. This is what I told you all. S1, S2, bulb L1 lighting up and the brightness, bulb L2 lighting up and the brightness. The two first instances are done for you all. Here you can see both S1 and S2 are off. Both bulb L1 and L2, they do not light up. And so if they don't light up, there's no brightness. Then the second instance, S1 is on, S2 is off. So bulb L1 lights up and the brightness is less. Bulb L2 does not light up and therefore there is no brightness. The same way we have to have S1 off and S2 on. Then both S1 and S2 on. Then you need to observe bulbs L1 and L2 and their brightness and fill up the table. So I am sure you all can understand what we need to do in this activity. So let's go to the lab and do the activity now. Okay students, so now I am going to do this activity in order to observe the current amplification process of a transistor or transistor being used as a current amplifier. So to do this activity, we need all these materials. Here you can see I have connected two dry cells. So 1.5 voltage each, that means 3 volts are connected here. Same goes here also. Two dry cells, 1.5 volt each. So altogether 3 volt potential. Then I have two switches. You can see both are in the off position. You can see here 0 is the off position. 1 is the on position, same goes for this. Then two light bulbs that also are connected. Then here you can see this is a volume control resistance, a variable resistor, a volume controller. You can see here I can rotate this knob and I can adjust the volume. This knob can be rotated so as to adjust the resistance. That is how we use the volume controller as the variable resistor. Then we have the transistor here. Now here it is marked as NPN, but from the arrow also you can identify the terminals. Now this terminal is the emitter. Always the arrow it comes with the emitter. So when the arrow is pointing outwards, you all know it is an NPN transistor. The current flow is shown by the direction of the arrow head. And this is the base and here we have the collector. So emitter, base and collector, it is an NPN transistor. Now you all can look at this circuit. We have the NPN transistor here, the same as this. Then look at this first circuit, that is the input circuit. Here you can see to the emitter, the switch is connected. Then here you can see the battery is connected there. Then you can see this component, that is the volume controller, that is connected here. Then we have L1, that is this. This is bulb 1 or light 1. And the transistor again to the base, the conducting wire is connected. And this is going to be the input circuit. This side is going to be the input circuit and this is S1. S1, L1 and the transistor, volume control resistance and the bulb. Then on this side, again you can see here emitter is common to both the circuits. Now again here this is the emitter. You can see both the wires are connected, this side and this side. Now, in this circuit diagram, of course, the switch comes here, but for you all to observe it more clearly, I have connected the switch here, but still it is in the second circuit. So, what I will do is, I will connect this. Instead of having the S here, I have put the S2 there. S2 is here. S2 here. Can you all understand that, students? Instead of having the switch 2 here, I have the switch 2 there. So now if you look at the circuit, now from the transistor emitter, there is a current wire, the conducting wire that is connected to the batteries. These are the batteries there. Then we have the bulb and the S2 switch. Is that clear to you all? So the bulb and the switch is there. That is going to be our output circuit. So first what we need to do is, you all have to understand the diagram. The input circuit, transistor, the emitter is connected to the switch, then the battery, then you have the volume control resistor, light, and again to the base. So emitter, switch, battery, volume controller, bulb, and the base. On this side again, emitter, then batteries, then we have the bulb and the switch being connected to the collector there. You all have to observe that. So, emitter, then we have the batteries, bulb, switch connected to the collector there. The two circuits. First, what we need to do is, we need to turn on switch 1, S1. So, first we will turn on this switch, that is S1. You can see the bulb does not light because the resistance has to be adjusted here. So, now I will adjust the volume controller. Here you can see until the bulb just lights. Now, here you can see the bulb lights. This is how we are going to use the circuit. Now, the resistance has been adjusted. Now, this is a table given in your textbook. You can see the positions of both the switches. So, here you can see S1 and S2. We have to have them in different positions and we need to observe the bulb, that is L1 and L2 here. We need to see whether they light up and the brightness. So, the first two of course is filled up for you all, but we will see whether that happens here as well. So, the first situation, both the switches are off. Now, here you can see the switch 1 is off, switch 2 is off. So, here L1 does not light up, so it doesn't light up. L2 also does not light up. So, that is the first stage. We have observed this one. Then the second combination, we need to switch on S1. Now, if I switch on S1, you all can see bulb 1, that is L1 lights up. Here you can see L1 is lights up and the brightness is less. You all can understand this is less brightness. Whereas if you look at L2, it does not light up. So, there is no brightness. That is the second instance. Now, the third instance, I will switch off S1. Here see S1 is off. Look at here, the switch also S1 is off. Now, S2 should be turned on. So, to do that, I'll turn on S2. Now, here you can see S2 is on. But can you see any bulbs lighting up? No. Both the bulbs do not light up. So, there is no brightness. Now, here you need to understand, students. In the first instance, when we had the light S1 on, this came on. L2 did not light up. But here in this instance, S1 is off, S2 is on, but both the lights do not come on. So, that is a difference. Now, what I will do is, I will turn on both the switches. The last instance, you can see, we need to turn on both the switches. So, I will put S1 on. You can see the light, bulb light, and S2 also on. Now, you can see both bulbs L1 and L2 have lighted up and the brightness of L1 is less, brightness of L2 is more. So, both lighting up, but this is less, L2 is more. So that is the last insert. Now what can you understand from this observation? We have the same potential difference. A less brightness means only a less amount of current is flowing through this circuit. So here this is, as I said, is the input circuit. Less current flows through the input circuit, whereas this circuit where you have L2, the brightness of the bulb is more. That means the current flow is also more. So that means this is the output circuit. Through the output circuit, the current is more. So less current through the input circuit, more current through the output circuit. So that means the current has been amplified. The current that was given to the input circuit has been amplified in the output circuit. That you can identify from the brightness of the bulbs. So I am going to switch them off. And you saw as I switched off S1 itself, both the bulbs went off. So this is what you all need to understand, students. Always for the circuit to function, S1 has to be on. Now here see, when S1 is on only, there is bulbs lighting. Here see S1 on, then only you see the bulbs lighting. So when S1 is on and S2 is off, still L1 lights. But when S1 is off and S2 is on, the bulbs do not light up. So from that you all have to understand, always there should be a current flow through the input circuit for the transistor to function as an amplifier. And also the current flowing through the input circuit is amplified in the output circuit. That is the current amplification process of a transistor. So that is what we understand from the brightness of the bulbs. Okay, students. So you were able to observe how the bulbs light up and the brightness of the bulb. And you can remember I filled up the table while observing the circuit and the bulbs lighting up. So first I will fill up the table here, then we will discuss what happens during the activity. So same as this, what was given to you, when we had both S1 and S2 off, both the lights did not light up. When we turned on S1 but S2 was off, you were able to see bulb L1 light with less brightness and L2 does not light up. Then when we had S1 and S2 off, what did you all see? You can remember both the bulbs did not light up. Both the bulbs did not light up. So because of that, there was no brightness. Then when we had both the switches closed, that is both S1 and S2 on, what happened? L1 lights up, L2 lights up, and how was the brightness? You can remember this was less and this was more. More or higher, we can say. So that is what we observe. So what can you understand from that? One thing you know, we need to on the switch for a current to flow through the transistor. That is one thing. That is the first observation. When both S1 and S2 are switched off, there is no current flow. Therefore, the bulbs do not light up. Then, when you turn on S1, that is the input circuit. Base emitter junction is the input circuit. If you turn that on, bulb L1 will light and it will be with less brightness. But because the output circuit is open, that is S2 is off, the bulb L2 does not light up. But when you have S1 off, that is the input circuit is open. There is no current flowing through the input circuit even if you close the S2. That is, you have a closed output circuit. Still there will be no current flow in the output circuit. So you have to give a current to the input circuit in order for the current to flow in the output circuit. Or S1 should be closed, and if current flows through base emitter only, there will be current flow through the emitter collector junction. That is what is indicated here. When you have S1 off, S2 on, both the bulbs do not light. But when you have both the switches on, there will be current flowing through the input circuit and the output circuit. And you were able to observe the amplification of current by looking at the brightness of the bulbs. L1 lights with less brightness, L2 with more brightness. So the current that is flowing through the input circuit is amplified in the output circuit. That is why L2 is more brighter than L1. So that is what you can understand from this activity. Is that clear, students? So we did the activity with the circuit. So here if I go back to the method, this is the input circuit, that is the output circuit. Always there should be current flow through the input circuit for a current to flow through output circuit. And the current that flows through the input circuit is amplified in the output circuit. That is observed from the brightness of the bulbs. L1 will be less bright, L2 will be more brighter. So you all know that the current has been amplified. So that is what we need to understand. So this is something that we have discussed, students. So we will try to understand what's happening here. This first point. So you can see, you may assume that the current flow is small if the brightness of the bulbs are low. And the current flow is large if the brightness of the bulbs are high. So that is how we were able to conclude from the activity. You all were able to see that the brightness of bulb L1 was less, brightness of bulb L2 was high. So from there we concluded, or we were able to understand what the current that is given as the input current is amplified in the output circuit. So there we assume this. Then, using these assumptions, we can draw the following conclusions. We can draw the following conclusions from the activity above. The first one, if you read the first one, a current flows in the output circuit only when a current flows in the input circuit. That you all were able to understand, no? When we had S1 open and S2 closed, both the bulbs don't light. Only when you have both S1 and S2 closed, then you see the bulb light. So there should be a current flowing in the input circuit for a current to flow in the output circuit. So that is something you understood. Then the second one, this point. Even when a voltage is given to the output circuit, a current does not flow in the output circuit unless there is a current flowing in the input circuit. The same thing that I explained to you all. When you close S2 and have S1 open, the bulbs don't light. So by closing S2, you provide a voltage to output circuit. But still the bulb does not light. So that is something you have to understand. Then the third point. When a small current flows in the input, that is when L1 lights up with a low brightness, a large current flows in the output. That is L2 lights up with a higher current. Is that clear? So this is also very important, what we discussed before. So L1 lights up with low brightness, that means less current is flowing in the input circuit and a large current flows in the output. So that is the conclusion that we got. And the large current flows in the output circuit. Then the input current is known as the base current. Why? We have the base emitter circuit as the input circuit. So input current is known as the base current IB and the output current is known as the collector current IC. Why? Because current flows from collector to emitter. So it is termed as IC and current IB is the input current. So if we go back to the previous one, that is here, this here we will have the IB current flowing, that is the base current, and here we will have the collector current IC flowing. So that is input circuit, that is output circuit. IB is the input current and IC is the output current. Is that okay? So then we'll move on back. So here, a small current IB in the input can be amplified into a large current IC in the output using a transistor. This is the process known as current amplification. So this is important. A small current IB in the input can be amplified into a large current IC in the output, and that process is known as current amplification. Is that clear, students? So here we observe the current amplification by observing the brightness of the bulb. So that is one function of the transistor. Transistor acting as the amplifier, and the first process is the current amplification process. You all saw the activity and you all have understood what happens during this process. So with that, students, I am going to move on to the next slide. So here we look at the second function, again amplification process of transistors, but here we observe the transistor as a signal amplifier. So earlier it was the current amplifier, now it is the signal amplifier. When we say signal amplifier, we can amplify audio frequency signals. You all know what audio frequency signals are. So this is the frequency that you can hear. So we can observe that that frequency, the audio frequency sound, can be amplified by the transistor, similar to amplification of current. So when we say signal amplifier, the transistor is frequently used not only as a current amplifier but also as a signal amplifier. How a transistor can be used to amplify an audio frequency signal is illustrated in the activity. So when we say audio frequency signal, we can write it as audio frequency AF signal. Audio frequency signal. So again, we give the audio frequency signal as the input to the transistor. So you will get an amplified audio frequency signal as the output. So this is the amplification process that we are going to observe now. This is given as input and that will be the output. So input will be the, what is the circuit? The base emitter circuit. Base emitter circuit. Here it will be the emitter collector circuit. So earlier we observed the brightness of the light bulbs and we observed the IB current and the IC current. But here instead of the light bulbs, we will be using an audio frequency generator as the input and we will use a speaker to hear the amplified sound. So here in this process, we will use an audio frequency generator for the input and a speaker to hear the output. So that is how we modify the circuit. But here also we will be using the NPN transistor that you all know. So you need to identify the terminals of the transistor, then we need to use an audio frequency generator and we need to have a speaker as well. So that is also an activity that we will be discussing after this. So with that, I'm going to move on to the next slide. So here I have the activity function of a transistor used to amplify an audio frequency signal. So to do that, we have all these apparatus that are needed. If we identify them, this is the transistor that we need. Transistor, again NPN. Then we need a fixed value resistor. Fixed value resistor. Earlier we used the volume control, that's a variable resistor, but here we are using a fixed value resistor. Then we use a speaker. Then we use a capacitor to provide the audio frequency signal. Then we have the battery case, battery cover, dry cells or batteries. Then we need a circuit board. We need the connecting wires. Then we have the audio frequency generator. Now, if we cannot use the audio frequency generator, what we can do is, we can use a small microphone to which we make a sound, audio sound, so that will be amplified in the output circuit. Either way, we can use the circuit. So, a transistor is needed, a fixed value resistor, a speaker, capacitor, battery cover, then dry cell, circuit board, connecting wires and audio frequency generator. So these are the apparatus that are required for the activity. I will move on to the next slide where I discuss the method of the activity. So here method, construct the circuit shown in the figure on the circuit board. So if we look at the circuit, here you can see this is the transistor, NPN transistor. You can see emitter, base and collector. Then the base, emitter, both the terminals are connected between these points A and B, where you supply the audio frequency signal. And here you can see the capacitor is connected to terminal A, which is connected to the base, that is the base terminal. So we connect a capacitor and we provide the audio frequency signal there. Then here you can see the base collector terminal is connected to a 22,000 ohm or 22 kilo ohms, means 22,000 ohms. That is a very high resistance, a fixed value resistor. So to make the base collector circuit reverse biased, there we need to provide a large resistance. Then what we do is, you can see here the emitter collector circuit is connected to the 3-volt battery because we need to supply current there. And then you can see the loudspeaker that is connected here. LS means the loudspeaker. Is that clear? So what we will do is, we will give the input here, audio frequency, and we will hear the output through the loudspeaker. So if the sound is amplified, you hear a louder sound, then you can understand that the amplification has taken place. So then, construct the circuit shown in the figure on the circuit board. First, connect only the audio frequency signal generator to the speaker and adjust the output so that the sound could be just heard. So you need to connect it to the loudspeaker so that you can adjust the sound so that only just the sound is heard. So then only you can understand that the amplified sound can be heard. Then connect a small signal from an audio frequency signal generator to the points A and B. So we need to connect the audio frequency signal generator there. Like I said, if we do not have the audio frequency signal generator, we can connect a microphone and make a sound into that. You can tap on the microphone or you can blow into the microphone so that you hear the amplified sound. Is that clear, student? So that is the procedure using the NPN transistor, the loudspeaker providing the audio frequency signal and the capacitor connected to the base. You can understand the signal amplification process of an NPN transistor. So now that you have understood the activity, let's go to the lab and do the activity now. Okay, students. So now I am going to do this activity in order to observe the signal amplifier function of a transistor. Signal amplification done by a transistor. So to do the activities, I have all these materials here. Now I have a dry cell. This is a 9 volt battery. Even if you use a 3 volt battery, that should be more than enough. Then I have the circuit board. In the circuit board, you can see this is the transistor. The 3 pins are already, now here I have already made the circuit connection according to the same diagram. So the 3 pins have been connected. First look at the diagram here. Now from this, now the arrow is pointed outwards. So what type of transistor is that? It is an NPN transistor. So here you can see the emitter is connected to the battery. So here also from this, the emitter is connected to the battery. Then thereafter, here you can see this wire is connected to the loudspeaker. This is the speaker here, which is denoted as LS in the diagram. And then when we look at the other connection, here you can see this is a fixed value resistor. You can see the color bands. You are familiar with fixed value resistors. So this is the 22 kilo ohm fixed value resistor, and then here this component is the capacitor. This is the capacitor. Here you can see 0.1 microfarad capacitor. Then on this side, between points A and B in the circuit, A is connected to the capacitor, which is connected to the base of the transistor, and point B connected to the emitter of the transistor. Now between these 2 points, we need to provide an audio frequency signal. Now to give that audio frequency signal, I have a microphone here and I have a stopwatch. You all know from the stopwatch we can hear the ticking sound. So that is a audio frequency sound, a sound that we can hear, and it is a very soft sound, so we can hear it faintly. Then if I hold the microphone near the stopwatch, you should be able to hear the amplified sound from the speaker. Then you will understand the function of this particular transistor as a audio frequency or audio signal amplifier. So this is the circuit. Like I said, the transistor, NPN transistor, emitter is connected to the battery, then to the speaker, then the base is connected to the capacitor, that is in turn connected with the audio frequency signal generator, that is the AF signal generator, that is again connected to the emitter. And on this side, between the base and the collector, you can see the speaker as well as the resistor, the very high value fixed value resistor. So first I need to connect the battery. Now here the battery is connected. You can see the positive and negative terminals connected properly. Negative terminal is connected with the emitter. Positive terminal is connected to the speaker and then to the collector. That is how the connection is done. So the battery is connected. The circuit is complete. Only thing we need to give the audio frequency. So like I said, I am going to use a stopwatch. From the stopwatch, we can hear a faint sound, the ticking sound. So first students will listen to the sound that is generated by the stopwatch without holding it near the microphone. If I leave it there, you will be able to hear a faint sound of the ticking of the stopwatch. Now I will hold it near the microphone. This is the microphone. Here you can see I am holding it near the microphone. Now listen to the sound carefully. Can you all hear an amplified sound? I am sure you all can hear it more clearly than before. So that is how the sound amplification or the audio amplifier function of the transistor occurs. You provide an audio frequency sound and then that sound is amplified and the amplified sound will be heard through the speaker. So for that we use this particular circuit where we use an NPN transistor that is connected in this manner. So now I have removed the microphone and the stopwatch also. This is the circuit we have here, students. So like you can see, the transistor is here, the speaker is connected to the collector, then you can see the battery connected from the collector, emitter collector circuit, the battery is connected, and here you can see the 22 kilo ohm fixed value resistor and the capacitor there. So from these two terminals, that is A and B or points A and B, we can give a audio frequency signal. Earlier in the activity, I gave a sound. So this was the sound coming from the stopwatch. I told you all I was able to hear the more amplified sound. I am sure you also heard it, but it's a faint amplification. But if we connect it to a audio frequency generator here, then of course you will hear the amplified sound even more clearly. So that is how we observe the amplifying process or the signal amplifier process of a transistor. So you all saw the way the sound is amplified. When we hold the clock near the microphone, you were able to hear a little more louder sound. Just to confirm that just for you all to see, because it's not possible for you all to see it and hear it as I am seeing it in the lab. So just to show you all that the speaker is working, what I will do is I will put a few regiform balls onto this, very light ones, and if I blow into this microphone, you can see the regiform balls moving, so you know that the speaker is working. That is just to confirm that part. So here you can see when I just blow, obviously you won't be able to hear so much of sound. You can see the balls jumping up and down, so you know there is an amplified sound coming from the speaker. That is one way to confirm that there is sound coming from the speaker. Okay, students. So you all saw the activity. I am sure you all were also able to hear the amplified sound. So when we tap into the microphone, the sound is amplified and you hear a larger sound through the loudspeaker. So from that you will be able to understand that the signal has been amplified. So here we give the input and get the output in the emitter collector circuit through the loudspeaker. So that is the activity. With that, students, I am going to move on to the next slide. So here, now you will hear an amplified output of the sound generated by the audio frequency generator. That is our observation. So from that we understand that there is signal amplification. And then the function of a capacitor. 0.1 microfarad capacitor has been connected to give only the alternating signal to the base. So this is important. Now we have the capacitor connected in order to provide the alternating signal to the base. And base needs a forward biasing voltage of 0.7 volt. Base needs a forward biasing voltage of 0.7 volt, and this is supplied through the 22 kilo ohm resistor. We forward bias the base by connecting a 22 kilo ohm resistor to the base collector circuit. Now you can remember in the diagram, here we have the 22 kilo ohm resistor. By connecting it here, the base is forward biased. So that when the audio frequency is supplied using the capacitor supplying an alternating signal, then there will be the signal being amplified and given as the output in the emitter collector circuit. Is that clear? So then I'll move on. So this is what you need to understand from this particular activity, students. The signal amplification process of a transistor. So with that, I'll move on to the next slide. So here again, we have an extra knowledge slide. So here, the apparatus required are given to you. We use a UM66 integrated circuit. You have heard about IC chips, electronic chips. So those are integrated circuits. A 220 ohm carbon resistor. Again, that is a fixed value resistor. A 3 volt battery cover. 2 1.5 volt dry cells, a circuit board and connecting wires. So using all these, we can do this activity, a circuit that can produce a musical audio frequency. A circuit to produce a musical audio frequency wave using an integrated circuit is shown below. And this circuit can be constructed on the circuit board to produce a signal for the audio frequency amplifier above. So you can use this circuit to produce a signal. If we don't have the signal amplifier, we can use this circuit to produce the signal. How do we do that? We can use a transistor there, and then what we can do is we can connect the transistor here. You can see what are the terminals. They are termed as 1, 2, 3. So they are the first terminal, that is terminal 1 is the signal. Then second terminal 2 is the positive supply. Here you can see that is connected to the positive terminal of the battery. And the third terminal here is connected to the negative terminal of the battery. So when we have a battery, a 220 ohm resistor, we have the UM66 transistor. The signal will be generated, audio frequency signal, and that can be supplied to the previous circuit. That is the circuit given before. You can connect it to the X and Y points, so that will become the audio frequency signal. So using that also we can do the activity. So this is another method of doing the activity, but we already did it using a microphone. You all were able to understand the signal amplification process of a transistor. So with that, students, I am going to end this chapter, and in the next chapter also I will discuss some more functions of the transistor.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.